Hi, this is the final video in the series where we're looking at the 2017 higher tier paper for Edexcel, and it's paper 2. In the previous videos we completed through to question number 20, so this I'm going to start again from question number 21. These are quite challenging, so I'm going to aim for about half an hour or so on this particular video. Please do stop the video, have a go at the questions, and then compare your solutions. Okay, so moving on then to question number 21, and this is basically a probability question which starts off fairly okay, and then it's a case of working through section B or part B of this. So there's 12 counters in a bag, there's an equal number of red, blue and yellow. So basically what they're saying is that there's 4 red, 4 blue and 4 yellow. Okay, 3 counters are taken at random and work out the probability of taking 3 red counters. Okay, so the first pick, well, there's 4 out of a bag of 12, so that's the probability of picking out a red counter. On the second pick, there are now 3 red counters in the bag and 11 counters altogether. And then on the third pick, there are 2 red counters left in the bag and 10 counters altogether. So if I multiply that through, I'm going to get 24 out of 1320, and that will reduce on your calculator to 1 out of 55. So part A of this particular question, there is a 1 out of 55 probability of picking out 3 red counters. Okay, then it says the 3 red counters are put back in the bag. All right, well that's good. So we're back to 12. Okay, and that means then that we've got 4 red, 4 blue and 4 yellow. Okay, that's fine. And then you've got this interesting little bit. It says some more counters are put into the bag. All right, just some. All right, and I think looking at the rest of the question, it's probably going to be easier if we kind of stop there and we say, actually, what I'm going to do is I'm going to add 2 more red, 2 more blue and 2 more yellow because I need an equal number. So now I've got to add 2 more, or add some more counters. Okay, and it's going to be the equal amount. So now red is 6, blue is also 6 and yellow is also 6. Okay, so then it says 3 counters and then taken at random. Is it now less likely or equally likely or more likely that the 3 counters will be right? All right, let's just work out the probability with these new bag of 18 counters altogether, the probability of picking the red 3 times. Okay, so the first time that we pick, so the first pick, okay, is going to be 6 out of 18. Second, well, there's now going to be 1 less red counter and 1 less overall. Okay, and then the third pick, there's going to be 4 out of 16. And if I multiply that through, I'm going to get 5 out of 204. So basically the question boils down to which is bigger, that or that, because remember that is where there was 12 counters and this is where there's 18 counters. Okay, so what I need to do in order to compare 2 fractions together, I've got 5 over 204 and I've got 1 over 55. Well, I need to make them both the same denominator. Now, fortunately, this is a calculator question, so therefore we can make the denominator 11,220 by multiplying 55 and 204 together. Okay, now I've multiplied 204 55 times to get that, so I'm going to multiply the top by 55. So I beg your pardon, I've multiplied it 5 times. Yeah, no, I'm going to multiply the top by 55, so I'm going to get 275. Okay. Next one is I've multiplied this by 204 times, so 204 times 1 is 204. So basically what we're saying is that the second time is more likely. So it is more likely because it actually boils down to 275 out of 11,220 as opposed to 204 out of 11,220. So that's the benefit of using a calculator. With those sorts of questions, you can deal with fairly big numbers without too much of a problem. You don't need to reduce them. You just need to make sure that the denominator is the same in order to compare thoroughly. Okay, let's move on then to question number 22. Okay, so this particular question is going to take a little bit of time to work through, but we're given a couple of functions. So the function of x equals 5x plus 3 and g of x equals that. And what we're going to do is find the values of a and b. Okay, so what I'm going to do is just have a look at the information that they give us first. Well, what they say first is that the g of 3 equals 20. Okay, that's fine. So what that means then is that if I put 3 into this equation here, I'm going to get a times 3 plus b. Okay, hopefully you can see that. So what I can say is that the g of 3 equals 3a plus b. Okay, now both of them equal each other, therefore I can write 3a plus b equals 20. So that's one of the first kind of statements that I'm going to use. The next thing I'm going to look at is this inverse function that is 33. Okay, so if I look at the function of x, I need to change it to the inverse function first. Now, there's a couple of different techniques to do that. The way I do it is I convert the function of x equals 5x plus 3 into y equals 5x plus 3. Okay, and then what I'm going to do is I'm going to make x the subject. So make x the subject. Okay, so in order to do that, I'm going to minus 3 from both sides. So I'm going to get y minus 3 equals 5x. Okay, and then I'm going to divide through by 5. So I'm going to get x equals y minus 3 divided by 5. Okay, and then I can convert this back. So I'll just write it left to right as x equals y minus 3 over 5. And then all I do is I convert that back again to now the negative function, or the inverse function of x equals x minus 3 over 5. Okay, now you might not be entirely sure about that particular process. There is a playlist on the channel with some more examples of how we do this, and please do have a look at those. And as I say, there are different ways, but this is by far and away the most common way of calculating this inverse function. Okay, now what I've got is the ability to take this value of 33 and plug it into here. Okay, so I'm going to now work out that the negative function of 33 equals 33 minus 3 over 5, which is going to equal 6. All right, so I'm getting a little bit more information here. Okay, the final little bit I'm going to look at is the g of 1, because I know that the inverse function of 33 equals the g of 1, so I need to get the g of 1. Okay, so let's have a look at that. The g of 1 is going to equal, now again, if I go back to my equation at the top here, or the function at the top here, I've got 1 times a plus b. So I can actually say that it's a times 1 plus b, or if you like, the g of 1 equals a plus b. So I've got some component pieces in place now that I can actually work through to try to figure out how I'm going to actually solve this. Okay, now I'm told that this and this are equal. So I'm just going to slide the paper down the screen a little bit, And I'm going to write in here that as the f of minus 133 equals the g of 1, I can write that 6 equals a plus b. Okay, and that's kind of what I'm getting to, because from here on in, really it's just solving this using a simultaneous equation, because I've got a plus b equals 6. And also, you might remember from the very first little bit that we looked at, we also have 3a plus b equals 20. So I can actually pop that into the equations, or the set of equations as well. 3a plus b equals 20. All right, so then it's just a case of treating them as simultaneous equations and working out the value of a and the value of b. So if I minus this, okay, I've got a minus 3a is going to be minus 2a. I've got b minus b, that's great, that disappears. And then I've got 6 minus 20 is going to be minus 14. If I divide through then by minus 2, I get a nice number of a equals 7. All right, and that's my first value, a equals 7. Okay, my next part of this is, I could use really any of the equations, but obviously the easiest one for me would be to do a plus b equals 6. So I've got a plus b equals 6. So that's going to be 7 plus b equals 6. And therefore, in this particular case, b must equal minus 1. Minus 1. Okay, that's actually the solution to this particular functions question. So it starts off fairly tricky, but actually towards the end, providing you kind of figure out those two equations, then you're able to use these two equations to be able to solve and find your values of a and b. Okay, hopefully that's okay for you. We're on the final question now, which is going to be question number 23. Now again, this is going to take a little bit of time to kind of work through. It's in, well, it just looks a little bit tougher, I think, because it's got these surds floating around. But really, what we need to do then is just have a look at that and see if we can figure out what it is they're talking about. So they're saying that given that that, 1 and that are the first three terms of S, find the value of x, and you must show all your workings. So what we're saying really is that we have, if you like, the first term is root x minus 1. The second is going to be 1. And the third is going to be root x plus 1. Okay? So what we're saying is that when we multiply something by that, we get that. Okay, so let's just have a look at that. We're going to say that something times root x minus 1 is going to give us a result of 1. Okay, so therefore I'm going to just make s the subject by dividing through by root x minus 1. So I can say that s, the something that we've multiplied this by to get to this, is going to be 1 over root x minus 1. Okay, so that's my first something. Okay, right, I need to work out my second something, okay, which is what I multiply this by to get to this. Okay, so what I'm saying is that something, and I'm going to do the same process again, times 1 is going to give me a result of root x plus 1. Okay, right, let's figure out what that something is. Well, again, I can just divide through by 1. So in this particular case, I've got another value of s, which is going to be just simply root x plus 1. Okay, so what we're saying is we have two values of s here. So both of them must be equal to each other, because it's a sequence where you multiply by the same each time. Okay, it's a geometric sequence. Okay, so an example of geometric sequence would be something like, say, 2, 4, 6, 8, where each time we're multiplying by 2, 2, 4, 8. Now you've got me going. 16. So we're multiplying each time by 2. Okay, so that's the example of a geometric sequence. So what we're saying is that these must be equal to each other. So I can say that 1 over root x minus 1 must equal root x plus 1. Okay. Right, so therefore, if I want to figure out the value, I can say, well, I can cross multiply. Okay, imagine that's over 1. Okay, so I can say 1 times 1 is 1 equals root x minus 1 times root x plus 1. Now, you might recognise that as basically the difference of two squares, because root x times root x is going to be x on its own, okay? And then they're going to cancel themselves out, and you're going to get minus 1 at the end. Okay, so I've jumped a little bit of a step there, but if you're at this sort of level, then hopefully you might recognise that root x times root x is x, root x times plus 1 is plus x, root x, minus root x is going to cancel themselves out, and then minus 1 times plus 1 is going to give you minus 1. So that will give me 1 equals x minus 1. Add 1 to both sides, I'm going to get finally x equals 2. Okay, so little bit complex, particularly to kind of get to these sorts of stages where you've got these two values of s and you've got to make them equal to each other in order to work out the value of x. All right, then it says show that the fifth term of s is that. All right, well actually this one's not too bad, okay, because what we're saying is that x equals 2, okay, we know that, and therefore each term is multiplied by root x plus 1, okay, we got that from this one at the top here, where are we? So this one at the top here, okay? So therefore we can say that each term is multiplied by root 2 plus 1, okay? And then it's really just a case of working that out from the first term onwards. So from the first term, I have a value of root 2 minus 1, okay? And that's what they tell us in the question. The second term is going to be root 2 minus 1, and I'm going to multiply it by the multiplier, which is root 2 plus 1. And that's going to give me my second term value, which is 1, which is what they've given us. Okay, let's move this on a little bit further. So now my third term is going to be my first term is going to be root 2 plus 1 multiplied by root 2 plus 1 again, which is this bit here, root 2 plus 1. So that's going to give me 2 plus 2 root 2 plus 1. And if I tie that up again, I've got 3 plus 2 root 2. Okay, now that actually is going to be my fourth term. Okay, so that's going to be my fourth term. Okay, so my third term is going to be root 2 plus 1. I'm going to multiply it by root 2 plus 1 again, because remember these are my multipliers, and I'm going to get that. Okay, so that's going to give me my fourth term, which is going to be 3 plus 2 root 2. Okay, and I'm going to multiply this by root 2 plus 1. And when I get my output, it's going to be my fifth term, which is what we're actually going to be asked to, or what we're being asked to prove. Okay, so I've got 3 times root 2 is going to be 3 root 2. I've got 3 times 1 is going to be 3. Okay, then I've got 2 times root 2 times root 2. Okay, so if you like, what I've done is this times this. Okay, now I'm going to do this times this. Okay, so root 2 times root 2 is root 4, which is the same as saying 2. Okay, so that times that is 2, times 2 is going to be 4. Okay, and then finally I've got 2 root 2 times 1, which is plus 2 root 2. Okay, so it does take a little bit of time to kind of work through, but when I gather up the like terms, I'm going to end up with 5 root 2 plus 7. Okay, so that's going to give me 7 plus 5 root 2. Okay, and that would be the answer to this particular question. Okay, so each of these terms, this is my first term. My second term is this because I've multiplied this by that. My third term is going to be this because I've multiplied my third term, which is root 2 plus 1, which they've told me at the top here, okay, by, again, my common multiplier. When I work that out, I get my fourth term. So my fourth term is here. I'm again going to multiply that by my multiplier, and that's going to give me my fifth term, which is here. Okay, so that's the end of this particular video. I'm sure you're quite relieved. That particular one is quite challenging to kind of work through, but hopefully you've been able to see what's gone on there, and we just need to make sure that we've got that common multiplication each time in order to get our final answer. Okay, please do add a comment below if you're not sure about anything. I'll always come back to you. Have a look out on the have a look at the channel, and on the playlist there are some other video series walkthroughs of various other exam boards, including AQA, and also more Edexcel as well. I hope it's been useful to you. Please do have a look at some of the other videos, and I'll look forward to seeing you inside the next video.